This is USMLE QA, USMLE material presented in a question and answer format structured similar to the first aid for the USMLE Step 1 book.
Question: what are the two processes discussed in the text? Answer: electron transport chain and oxidative phosphorylation. Question: how do NADH electrons from glycolysis enter the mitochondria? Answer: NADH electrons from glycolysis enter the mitochondria via the malate-aspartate or glycerol 3-phosphate shuttle. Question: how are FADH2 electrons transferred to complex 2? Answer: FADH2 electrons are transferred to complex 2 at a lower energy level than NADH. Question: what is the result of the passage of electrons? Answer: the passage of electrons results in the formation of a proton gradient. Question: how is the proton gradient used to drive the production of AT? Answer: the proton gradient is coupled to oxidative phosphorylation to drive the production of AT. Question: what is the function of NADH and FADH2 in the electron transport chain? Answer: NADH and FADH2 are electron carriers that transfer electrons to the electron transport chain. Question: what is the role of the malate-aspartate or glycerol 3-phosphate shuttle in the electron transport chain? Answer: the malate-aspartate or glycerol 3-phosphate shuttle is a mechanism that allows NADH electrons from glycolysis to enter the mitochondria and continue on in the electron transport chain. Question: how is energy converted in the electron transport chain? Answer: energy is converted in the electron transport chain as electrons are passed along the chain and energy is used to pump protons across the mitochondrial membrane, creating a proton gradient. Question: what is the relationship between the electron transport chain and oxidative phosphorylation? Answer: the electron transport chain and oxidative phosphorylation are closely linked, with the electron transport chain generating a proton gradient that is then used to drive the production of AT through oxidative phosphorylation. Question: can you explain what is meant by the term proton gradient? Answer: a proton gradient is a difference in the concentration of protons on opposite sides of a membrane. In the context of the electron transport chain, a proton gradient is created as protons are pumped across the mitochondrial membrane during the transfer of electrons. Question: how does the proton gradient drive the production of AT? Answer: the proton gradient drives the production of AT through a process called chemiosmosis. As protons flow back across the mitochondrial membrane through a protein complex called AT synthase, the energy from this flow is used to convert ADP to AT. Question: how does the electron transport chain differ in complex I and complex 2? Answer: complex I and complex 2 differ in the electron carriers that they accept. Complex I accepts electrons from NADH, while complex 2 accepts electrons from FADH2. Additionally, complex 2 does not pump protons across the membrane, unlike complex I. Question: how does the production of AT through oxidative phosphorylation compare to other AT production pathways? Answer: oxidative phosphorylation is considered one of the most efficient ways to produce AT, as it can generate a large amount of AT from the oxidation of a single molecule of glucose. Other pathways such as substrate-level phosphorylation in glycolysis or photophosphorylation in photosynthesis can also produce AT, but typically generate less AT per molecule of substrate.
Thank you for watching our Q&A format video. We hope this helped you learn, review, and retain knowledge needed for the USMLEs. For more information on this topic, check out the link in the description. Now, if you want to take your USMLE prep to the next level, be sure to check out all our courses, which are structured to follow along with the first aid for the USMLE Step 1 book. You can find us at usmleqa.com. And if you're watching this on YouTube, be sure to like and subscribe.